So we're ready for our final lecture in JavaScript asynchronous programming. So we've looked more into JavaScript callbacks and JavaScript promises, both of which are going to be used here to make network requests asynchronously. So network requests are API calls, and really this is the primary use of asynchronous programming in JavaScript. Why? It's because the browser user interface is event-driven. Like all graphical user interfaces, the underlying operating system, Windows, Mac, Linux, phone, and tablets, the user interface here is all event-driven. Events that are primarily triggered by the user and user actions. Think of keyboard and mouse. So there's an event loop that handles each one of those events. So every key press is an event. Every mouse movement is an event. In fact, applications that are in the middle of an event loop are getting really a storm of events sent to them by the operating system, in the case of a Windows app or a Mac app, on the native desktop app. In our case, the browser is the native desktop app, so it's receiving events from the operating system, the host operating system, and it's translating them into events for JavaScript, which internally, right, remember for JavaScript, the browser is the machine. So internally, the events are to us from a JavaScript perspective, these events are coming from the browser. User actions, keyboard and mouse actions. So as I move the keyboard and this mouse over the face of this, the application is actually getting a storm of messages from the operating system, from Windows, because this is PowerPoint and it's a Windows native application. So it's getting a storm of information from the browser. And look how it is behaving a little bit. Look at how it blinks out the mouse cursor after a while. That's PowerPoint taking unique action for the mouse event that other applications don't do, for example. So that's why graphical user interfaces are so flexible. They're really tied to the user. And if you don't think about, let's say, individual key press being an entire event, but it is. So these events have to be handled quickly to keep the event loop running smoothly. Otherwise, it looks like you have a frozen application on a desktop or a hung application on a page that won't load. Right? So that if the user action stays within the browser, the request can be handled in milliseconds. And that's what's required to keep that extremely busy event loop running smoothly. Think about if a user action requires network information from the server. A network API call will be made. This request cannot be handled in milliseconds. It might be seconds, it might be really fast, but it's not going to be milliseconds like a key press in a text box would be. So what will that will stop, since that's an event that was triggered inside the browser and that in turn led to a network request. That pause is going to be noticeable by the user and by the browser, and it will start to report page load problems. And that's what it'll appear to be to the user. If you're on a native Windows machine and your application is not responding quickly enough to the event loser, and it's with any really events have to be handled really quickly, or the operating system will say this application doesn't seem to be responding. Right? It might be perfectly healthy. It's just taking a long time to handle an event. It's really a no-no in terms of programming event-driven systems to have a slow responding action. Okay, so that's why we need asynchronous technologies to do network calls, because asynchronous, remember, launches essentially a thread of execution to go out and make the network call, and it returns immediately. So now, from the browser's perspective, that event has been handled. The entire action has not been complete yet, because we still have something pending that we launched on another thread. But from the event loop's perspective, it's been responsive, the action. So anytime you have slow event handling in GUI systems, it leads to trouble. So that's why we have asynchronous calls in general, and that's why asynchronous calls are important from a JavaScript perspective, primarily making network calls. Okay. So we're going to see the modern way to do networking calls, which is fetch, the fetch method. So I have the first line here, let promise equals fetch with the URL or optional options. So fetch URL. And the response is going to be a promise. Remember the promise, the JavaScript promise this returns. So we're going to have then and catch methods, we'll see. These should be familiar looking to you now since we've spent time with promises. The promise is plumbed for async programming. And since we've spent time there, the fetch will look natural. So for a REST API, a GET request is just the URL. That's equivalent to what the browser does. But if you need a post, put, or delete request, you need to add the optional options to the URL, what's in brackets above. And that will be a JavaScript object, very flexible, and we'll get into that in some examples. So we're going to see a beautiful example from a tutorial site from, I think, Tanya Rasia is the writer of this, and we're going to look at her example next.